Hello Year 10 and welcome to today's lesson. Once again we'll be continuing to look at completing the square, making those expressions a little bit more complex this time once again. You'll have a live lesson on Friday this week, and in that lesson you'll be looking at each of the 3 different skills we practiced this week and tying it all together. At times today you will need your maths book to make notes and work through the independent practice. You won't need a calculator to answer these questions, however you may find it useful to double check your answers after. And you may at times want to use your whiteboard. To start today's lesson, can you go ahead and pause this video and have a go at the do now? Okay, I'd just like to look at question 1 today. The other questions we have previously looked at and have been covered in other lessons. For question 1, this is very similar to what we were doing yesterday. You want to be able to write this into the format of x plus a number squared plus another number. To do this, I want to take my brackets and place in half of the coefficient of x. So that's going to be plus 3. This then is squared. I then want to subtract this number squared. So I'm going to subtract 9 because 3 squared is 9. Sorry, I didn't need to write the squared. And then add 4. The last thing I want to do is combine these two like terms. Negative 9 plus 4 is going to create negative 5. So I've still got those brackets, squared, subtract 5. If you're unsure on that, please make sure that you have watched yesterday's lesson before you have a go at today's lesson, as we are going to step this up another level and make it a little bit more complex. Okay, here are the rest of your answers. And can you please pause the video here and write down today's date and title? You don't need to write down the key words, as we've already written them down previously. Okay, one thing I would like to add to this definition, you don't need to make a note of this into your book, I just want to show you it. So far, we've only been looking at quadratic equations that look like this, where we have no coefficient of x squared. But today, we're going to put that coefficient in there. Now, you'll have seen in previous lessons, particularly when we looked at using the quadratic formula, that the number next to x squared, that coefficient, is often referred to as a. Now, if I look at this equation over here, you'll notice that so far I've created 2 new terms, d and e. Now, they may happen to be the same as some of these numbers, but they don't have to be. So we can't just pick them up and drop them in. However, this a, I'm going to place an a just here. That number is going to be the same, and I'm going to show you how we make that the case. So this a will go outside the bracket, but d and e will not just be picked up from the previous equation. We'll be finding d and e much like we have in the previous 2 lessons when completing the square. Okay, so as I said, today we're looking at a question where you have a coefficient of x squared. So far you've only looked at where it starts at x squared. We're going to have a number in front this time. And as I've just shown you on the previous slide, this number here is actually just going to go outside the brackets there. But it is going to have some influence, therefore, on some of the other numbers that happen. Now, to start the lesson, I want to actually just expand this left-hand side and show you that it is in fact equal to the right-hand side. So I'm still going to have 4. That x plus 2 bracket must be written out twice. And then I've got subtract 12 on the end. This 4 is only multiplying these numbers here. So I've got 4, and I'm going to expand my brackets, then I'll multiply by 4 after. So I'm going to keep this in brackets. I'm going to get 4 x squared plus 2x plus 2x plus 4, and I've still got that subtract 12. Combining these 2 like terms, I can simply write it as 4x. Now I'm going to multiply each of these terms by 4, and then after combine this in. So I'm going to get 4x squared plus 16x plus 16, and I've got minus 12 on the end there. We'll now get 4x squared plus 16x plus 4. And I do apologise, it looks like I've made that common error and I've written this number out wrong and I typed it earlier. Okay, so it should say plus 4 on the end there. So we're going to look at how now we take this format here and turn it into this format. So to start with, I want to rewrite this expression here to make it look like an expression that I already know how to solve and turn into a completing the square form. I do not currently have a method where there's a 3 there, but I do have a method if it was just x squared. So I'm going to factorise this, and I'm going to factorise out that 3. And I'm going to use big squared brackets here because there's going to be quite a few brackets involved. When I factorise out 3 from this term here, I'm just left with x squared. If I factorise out 3 from here, I'm left with plus 8x. If you were to expand this, if you were to pretend these were curly brackets and expand it, you would get this up here. Now looking at this, okay, I've got that 3 there, and I'm just going to leave it. I'm just going to leave it outside some big square brackets. But inside the square brackets, I know how to complete the square on this. So I'm just going to complete the square, and this is where now my curly brackets are going to come in. Completing the square on this, I open up my brackets, and I add on half of the coefficient of x, close brackets and square, and then I must make sure to subtract this number squared. 4 squared is 16, so I subtract 16. All that's left to do now, because this isn't quite perfectly written in this format yet, there's still too many brackets, is to re-expand this back out. I'm going to have 3 lots of this bracket squared. So I've taken the 3 and I've multiplied it by this bracket. I've just placed them together. That shows that multiplication. And then I want to take 3 and multiply it by negative 16, which is going to give me negative 48. So step 1 is to factorise out the coefficient of x squared to create a quadratic that we know how to complete the square on, and leaving this in square brackets. Then, again, leaving it all in square brackets and that coefficient on the outside, complete the square on the inside. Finally, re-expand those square brackets to give you your final answer. Please pause the video here and write this down as an example into your book. And have a go at the one on the right. This time I want to factorise out 2 to leave me with x squared, and then that's also going to give me positive 6x. Completing the square on those terms in the square bracket, it's going to give me x plus 3 squared minus 9. Finally, re-expand those square brackets. I've got 2 lots of this bracket squared minus 2 lots of 9, which is 18. Oh, I do apologise, that's in the way. So what happens now if we have a plus c on the end? Well, you've actually got 2 options here. I only realised the other day that when I was in year 10, I would always use the more complex method. So I'm just going to show you the simpler method. Because there's less expanding and multiplying to do at the end. There is no harm in doing the method I used to use. It's just that you're more likely to make a mistake. So I want to create this part here into something that I know how to complete the square on. So I'm going to factorise out 2 to leave me with x squared. And then I'm also left with 6x. Now what I used to do is also factorise out this number here. I would also write plus 9 here. But you don't need to do that because that then means later I've got to multiply again. So what I'm going to do is just leave that, and I'm going to put it right over on the right hand side. I'm going to leave that on the end. Because this can be combined later. This is a number on its own. This is not involved when I complete the square on this part. So I'm just going to complete the square on this section here. So I'm actually going to turn this into square brackets because that's what I would normally do. So completing the square here and making sure I keep those 2 terms carried down on the outside. So I've got 2. Completing the square on x squared plus 6. X will give me x plus 3 squared minus 9, close brackets, and I've still got that plus 18 on the end. Expanding this part back out, remember this 2 is just times these square brackets, so I'm going to have 2 lots of x plus 3 squared, take away 2 lots of 9, which is 18, and I've still got that plus 18 there on the end. Finally, I want to combine like terms, and it happens to be that this time these two terms cancel each other out. That won't always happen. Sometimes they will add up and create a number on the end. So my final answer is 2x plus 3 squared. Please pause the video here and write this down as an example. Okay, for the one on the right, I'm going to show you the alternative method that I would have once used. I would like you to first have a go at starting it, and then in a few moments I will begin to solve it and explain my process. It's subtly different to the one I've done on the left. Either method will work. So the first thing I want to do is factorise out 3 to leave me with x squared plus 6x. Now you'll notice this one is actually turning out very similar to the one on the left. Now on the left, I just left the plus 18 on the outside. This time I'm also going to factorise it out and leave it in those square brackets. So I'm going to factorise out 3 from 27, which leaves me with 9. Now I want to complete the square on everything in the square bracket. So this time we must make sure that we include this plus 9 when we complete the square. So completing the square, I must have x plus 3 squared minus 9, and then I've also got a plus 9 on the end there. This minus 9 is this 3 squared subtracted, and then I've added on that number there again. I can simplify this because these two cancel each other out, and expand the brackets again, I'm left with 3x plus 3 squared. So you can, if you want to, leave that plus c term on the outside, or you can also bring it into those square brackets and factorise that also. At this point where they factorise nicely, there isn't really a benefit to either method. However, later, when you are maybe trying to factorise and you're going to start creating some fractions, you may choose instead to leave that number on the outside so that you don't end up with some awful fractions. Okay, so let's look at this one now. This time I'm going to factorise out 4 and leave in my square brackets x squared plus 2x. And I'm going to leave that plus 12 right on the end there. I'm not going to factorise that. Completing the square on what is inside the square brackets gives me x plus 1 squared, and then subtract that 1 squared, which is going to give me minus 1, and I've got plus 12 on the end. Expanding these brackets out, I get 4x plus 1 squared, and then I need to do 4 times that negative 1, so it's negative 4, and I've got plus 12 on the end. Combining like terms gives me 4x plus 1 squared plus 8. Please pause the video here and write this down as an example. And have a go at the one on the right. There is your answer. Okay, this time I want to look at what happens when there's a negative in the middle there and see if that has any real impact on what happens at the end. I still want to factorise out 3 here. Factorise out 3, which is going to give me x squared minus 7x this time. And again, I'm going to leave that plus 6 on the outside. Notice this time, not only is it negative in the middle, but we've also got an odd number, which means when I complete the square, I am going to create a fraction. That's why I also prefer to keep this 6 outside. It's much easier to combine later. Completing the square on what's inside the brackets, I get x minus 7 over 2, all squared. Remember, I always like to leave it as a fraction rather than working it out as a decimal. And then I need to subtract that number squared. 7 squared is 49, 2 squared is 4. And I've still got plus 6 on the end there. Up next, I want to re-expand these brackets. So I'm going to have 3x minus 7 over 2 squared minus 49 over 4 multiplied by 3, which is going to give me minus 147 over 4. And I've still got plus 6 on the end. Now combining these, I want to combine these two numbers together just to create one plus c term on the end. To do this, I'm going to do some additional workings out over here. I need to combine negative 147 over 4 plus 6. Well, if I can turn 6 into a fraction with the same denominator, which means I want to do 6 over 1 and multiply it by 4 to get me 24 over 4, I can now combine those two fractions, which is going to give me negative 123 over 4. So my final answer is 3x minus 7 over 2 squared minus 123 over 4. Now, if you got to this step and this fraction simplified, always simplify it. This one can't. 123 does not divide by 4. It also does not divide by 2, so I can't even simplify it half. Can you please pause the video here and write this down as an example? And have a go at the one on the right. For this question here, when I've got to this step, rather than trying to combine 98 over 4 and 10, I actually want to simplify this fraction first. 98 over 4, I can take out a factor of 2 and write this as 49 over 2. So now this part here can be rewritten as negative 49 over 2 plus 10. 10 is the same as 20 over 2, so I've got negative 49 over 2 plus 20 over 2. 20 over 2 would simplify to 10, and combining these will give me negative 29 over 2. So my final answer is 2x minus 7 over 2 squared minus 29 over 2. Okay, I'd like you to pause the video here and have a go at these questions in your books. The first set of questions, there is no plus c on the end, so that's going to be slightly nicer when you are combining like terms. But for question 2 there is, and as you get into some of the later problems, you'll see that some of them are not going to factorise very nicely, so think carefully about what you do there. And there are your answers. Okay, you've made it to the end of today's lesson. Please make sure you upload a photo of your work to Frog and also complete the Frog quiz attached to this assignment.